Hello everyone, welcome to SCI-EASE. In the last two videos, we discussed about the laws of chemical combination, that is, the law of conservation of mass and the law of constant or definite proportion. So now the scientists, they have the target to find out the explanation for these laws. So at that time, one of the scientists, you can say British chemist John Dalton, he gave the explanation for these laws of chemical combination, both these laws, and he picked up the word atom from the Greeks, and he gave the explanation that all matter that is made up of the smallest particle known as atoms. So John Dalton, he gave the explanation for the nature of the matter. The matter which may be in the elemental form, in form of element or compound or a mixture, all are made up of atoms which are indivisible particles at that time. So he gave certain postulates to explain the theory given by him, and the theory given by him was Dalton's atomic theory. So in this video, we will take up the Dalton's atomic theory, its postulates, and what are the limitations of this theory. Now, the first postulate of this theory was the matter is made up of tiny particles called atoms. I have told you that when we will break this matter, suppose this pen is a matter, when we will break it, it will result in the formation of tiny particles which are known as atoms. So, first postulate is this, that every matter that is made up of the smallest particle known as atoms. Now, the second postulate of his theory is atoms are indivisible particles. Okay? They are indivisible, means they cannot be divided further. And these atoms, they cannot be created or destroyed in a chemical reaction. I have taken one example in the last video. In one of the video, I have taken the experiment in which sodium carbonate and copper sulfate was taken. Okay. So here, what will be the product? Sodium sulfate and copper carbonate that is formed. This means that during this chemical reaction, atoms, they cannot be created or destroyed. There is no destruction of sodium atom, there is no destruction of copper, there is no extra formation of the sodium or copper. What takes place here? Only the rearrangement of the atoms that takes place. Okay, here only the rearrangement of atoms takes place. In all the chemical reactions, you will see that there is only the rearrangement of atoms. So atoms they cannot be created or destroyed during the chemical reaction. This is the second postulate of this theory. Now the third postulate, that is, atoms of the given element, they are identical in mass and chemical properties. Suppose I take this gold coin. Okay, this gold coin is made up of number of the atoms of gold. Means all the atoms which are present in this gold coin, they are identical. They are all gold. They are made up of gold atoms. They are same, having the same mass and the chemical properties. Okay? So if we are taking oxygen atom, if we are taking this oxygen which is present in the air, so this oxygen which is made up of number of the oxygen atoms that are same. They are identical and they have the same chemical properties. I think that this point is clear to all of you. Now next point is atoms of different elements have different masses and chemical properties. If the atoms are same, which I have taken this gold coin, in this, all the gold atoms, they are identical and they have the same chemical properties. But if I am taking the case of HCl, okay, here H is smaller than this chlorine, which is a bigger one. So here, atoms of different elements. This is the hydrogen atoms and these are the chlorine atoms. So, chlorine and hydrogen, they have different masses and different chemical properties. Okay, if the atoms we are taking different elements, then atoms of different elements we are taking, this means that they have different masses. As you know, hydrogen, it has different mass than the chlorine. Okay. Now the fifth postulate is atoms combine in the ratio of small numbers to form the compound. So you know that atoms, they, like we are taking the case of HCl. Here the atoms of hydrogen, or you can say one molecule of, we are taking hydrogen and one molecule of chlorine, they combine together to form two molecules of HCl. So the atoms combine in the ratio of small whole numbers to form the compound. So the compound HCl that is formed. The last point, that is, the relative number and kinds of atoms are constant in a given compound. In a given compound, the relative number and kinds of atoms, they are constant. Suppose we are taking the case of water. In water, there will be 2 atoms of hydrogen and 1 atom of oxygen. We can't change the formula of this water. If we will change like this, H2O2, then what is formed? It is the different compound. This is hydrogen peroxide. If we are changing the number of the oxygen atom, then the different compound having different properties that is formed. So the relative number and kinds of the atoms are constant in a given compound. So in all, there are 6 postulates of Dalton's atomic theory, and that has contributed, Dalton has contributed a lot, but as discoveries, you know that they are continuing and they're continuously scientists, they discover the things, then some of his postulates, they have the limitation, they prove to be wrong. So I'm taking up now the limitations of Dalton's atomic theory. Now next is the limitations or the drawbacks of the Dalton's atomic theory. The first postulate of Dalton's atomic theory was that matter is made up of the smallest particle, which is indivisible, known as atoms. Okay? Now the limitation is that atom is no longer considered as the smallest indivisible masses. Up to 500 BC or around 18th century, it was found by the philosophers and the scientists that matter is made up of smallest particle known as atom, which is indivisible. But you know that scientists, they discover new things. So after some time, the scientists discovered that atom is divisible. It has 3 subatomic particles in it. So the names of the particles, they are protons, neutrons, and electrons. So, the structure of atom that was given by the scientist, that nucleus that is present in the center. Nucleus is present in the center where there are 2 particles, protons and neutrons. Okay? And which are responsible for the mass of, or you can say atomic mass. And there is extra nuclear region around the nucleus in which the electrons, they revolve. Okay? So, the nucleus is there where there are protons and neutrons, and in the extra nuclear region, these orbits are there where the electrons, they revolve. Okay? So, the first postulate of Dalton, that was proved to be wrong, because now the scientists have discovered that atom is divisible and it has 3 subatomic particles known as protons, electrons and neutrons. Protons and neutrons, they are present in the nucleus of an atom, and the electrons, they are present in the extra nuclear region, and they revolve in the definite path known as orbits or energy levels or shells. Okay? Now this is the limitation. Now next is atoms of the same element have same masses. This was the postulate of Dalton. But here, atoms of the same element may have different masses. Here the best example, I will give you very easy example, and that is of hydrogen. Hydrogen has 3 types. The term I am not speaking here. Here the masses are, in one hydrogen, the mass, it was found out to be 1, in second 2, and in third it is 3. Okay? And the atomic number that is written as a subscript on the left hand side of the symbol. Atomic numbers, they are same, and masses, they are written as a superscript on the left hand side of the symbol. Okay, so the limitation is atoms of the same element is hydrogen. It may have different masses. Atomic number, the definition of atomic number I want to tell you, it is equal to atomic number that is equal to number of protons or number of electrons in the neutral atom. Okay, in neutral atom. And what is atomic mass? It is equal to number of protons plus number of neutrons present in nucleus of the atom. Okay, this means that protons, they are same in all the three hydrogens, but number of neutron, that is different. Okay, in this case, the number of neutron, that is 0. Here the number of neutron, it is 1, and here 2. So what are these? These are known as the isotopes. Isotopes. Okay, this term is new for you. Isotopes, they are the species in which the same element has same atomic number but different atomic masses. So the postulate that the atoms of the same element have the same masses, that was also proved to be wrong, because some of the isotopes, they were discovered. And I will take up another example also. Carbon has also 3 isotopes. Here atomic number, that is same, that is the number of the protons or the number of electrons, that is same in all the 3 forms, but 3 isotopes of carbon, but the masses, they are different. Here carbon 12, carbon 13 and carbon 14. This means the number of neutrons, they are different in these 3 isotopes of carbon also. Okay, so the term, which term? Isotope, that is given where the species of the same element, they have same atomic number but different atomic masses. Now come to the next limitation. Atoms of the different element may have, atoms of different element may have same masses, but his postulate was atoms of the different elements have different masses. I have taken the case of HCl. Okay, so here I will use up another term, okay, that is isobar. Isobar. So I will take up the example that elements, they are different. I will take up potassium and calcium. In both these cases, the mass is 40. In potassium also, the mass is 40, but they have same masses. Elements are different. One is potassium, another is calcium. But their atomic numbers, they are different. That is 19 and 20. And what are these species known as? What are these species known as? These species, they are known as isobars. Iso means same, bars means weight. Okay, they have same atomic masses, but their atomic numbers, they are different. So this is another limitation of Dalton's atomic theory. Now the last limitation is substances made up of the same kind of atoms may have different properties. So the substances which are made up of same atoms, they may have different properties. You can take the case of this. You can take the case of, I will tell you a very simple example of allotropes of carbon. Okay? One is diamond and another is graphite. Both are made up of carbon. But they have, the atoms, they have same, both diamond and graphite have same kind of the atoms. But they have different properties. How? Diamond is considered to be the hardest substance known. And graphite, that is very soft. Diamond is bad conductor of heat and electricity, but graphite is good conductor of heat and electricity. Okay, so with the passage of time, when the scientists discovered new things, the limitations of the Dalton's atomic theory, that was highlighted, and I have told you the 4 limitations or the drawbacks of the Dalton atomic theory. I will repeat once again. Atom is no longer considered to be the smallest indivisible particle. It has 3 subatomic particles, that is protons, electrons and neutrons. Here atoms of the same element may have different masses. Here I have taken the case of isotopes. And third is atoms of the different element may have same masses. Here I have taken the case of isobars. And the last one, that substances made up of the same kind of atoms, they may have different properties. Here I have taken the case of allotropes of carbon, that is diamond and graphite. You can study the properties. They are altogether different, as the structure is also different. So this is all about the postulates and the limitations of the Dalton's atomic theory. I think the things, they are clear to all of you. I have taken many examples to explain each and every point. I will meet you in the next video with another topic of class 9th of this chapter only. Till then, thank you very much.